Hello, everyone, and welcome. We're going to get started in just a minute here. We are so fortunate to have David Porras with us today. You've probably seen Dave's work on Twitter. I know every time I see some interesting things about Mathagon, I'm immediately impressed. Then I go to do it, and then I kind of get sucked down the rabbit hole of all these really great visual ways of representing math. So Dave's here today to share with us some great examples. We're going to look more into the middle school side of it, but I know so many of you educators and the way that we can take something from one grade level and stretch it, bring it down to our elementary, down to our primary, up to our high school, and so on. So without further ado, I'm going to go ahead and have Dave get us started. And then as other people come in, I'm going to continue in the chat box to welcome them, make sure that they have access to everything as well. So Dave, I'm going to go ahead and send it over to you.
Awesome. Thank you so much, everyone. Thanks for that nice introduction, Teresa. It's great to be here. I've been on a few of these over the years, and to be invited to share is really such a great honor. So I'm excited to be here and talk math with you all. Hope to make this interactive. We're a small group right now, so feel free to unmute if you have a question or put your name in the chat and ask a question. We'll be doing some math together. As Teresa said, my name is David Porras. I teach 7th grade math outside of Boston, Massachusetts, and Weston, Massachusetts. I've taught 6th and 7th grade for over 20 years now, and I've been working on the content team at Mathagon for the last year and a half or so. I came across Mathagon, I think, through a Twitter something or other about 2 years ago, as I was looking for ways to engage my students in mathematics, have them play, enrich, and I saw they were looking for folks to join the content team, and I was lucky enough for them to take a chance on me, and I've really enjoyed connecting with folks through Mathagon over the past year and a half. So I'm excited to share some of the tools that we have of ways that you can engage students in playing with mathematics. We call Mathagon a mathematical playground, just a place for kids to go explore, try, have fun, be creative. And I want to start with just one quick kind of warm up. I will show you where in a minute where you can find this task on Mathagon, but let's just do it together here. So I'm going to take these cards, you can see that are numbered 1 through 10. I'm going to turn them all over at the bottom of the polypad. So on Mathagon, there's a range of activities. There's courses, there's activities, there's games. The main feature I'm going to be talking about in this webinar is polypad, our virtual math tools and manipulatives. And so I'm on polypad now. This is a canvas that I made. Again, I'll show you where you can find this later on so you can do it on your own. But let's just do it together. So I'm going to turn all these cards over. I'm going to stack them. There are buttons at the bottom of the polypad. I'm going to stack them up. I'm going to shuffle them so they're all in random order. I'm going to hit shuffle a few times just to really shuffle them. And then I'm going to draw the first card. I can double click on the deck to draw a card and put it on one side of the scale. And then I'm going to draw the second card and put it onto the scale. And I'd like you right now in the chat, make a random guess about the two cards. What do you think the two cards are? Anything, right? We saw what the cards were. This is how I might do with students. Just any random guess. 5 and 7 says Lisa. 2 and 5, Karina. 3 and 9. 5 and 5 says Laura. 2 and 6, Molly. Awesome. Great guesses. Not much information to go on right now, so let's add some things to the scale. So I'm going to take this 5 dice and put it on the scale. Ooh, anyone want to update their guess? If you haven't used polypad before, the cards and the dice, they work together on the scale. So the fact that the scale didn't move gives us some information. I'm going to try not to be too leading. Molly is sticking with 2 and 6. Awesome. So this is telling us that those are heavier than 5, right? If I were doing this in class, I might take this little box and slide it over a little bit to show that that's not possible. I'm going to roll this and see what happens. We can do randomize and get some more information. All right, let's put a second one on here. So I'm going to put the 2 here. Still heavier than 6, so I would certainly be doing this as a conversation in school. Let's see if we can figure out what these cards are. Continue to update your guesses in the chat. More than 7. All right, let's flip that, roll them again. Sticking with 10 and 1. Awesome. More than 7. At some point, we might want to put this third one on here. Oh, there's a good piece of information. More than 10. Let's put this third one on here. All right, what do we got? Oh, less than 14. Right. Again, I'm sharing some thoughts that I would certainly have students be doing. New guess. All right. Final guesses in the chat. Let's see if I can give us some more information to work with. We have some new guesses, some people sticking with their first guesses. Oh, that is a good piece of information. Couldn't have planned that better myself. I do not stack the deck here. I don't know what the cards are. What is that? 11. All right, so now certainly a good conversation. What are all the possibilities here? We had cards numbered 1 through 10. 11 is a good number, changing to 7 and 4. All right, final guesses in the chat. Let's see them. We got 5 and 6. Was there anyone still on their original guess? I haven't been paying careful attention to the chat. Gail, was that your original guess maybe? Awesome. All right, so now let's see one card. Lisa's at -4 and 7, right? Lisa, no, just joking, sorry. I know, that's a dash. A bad math teacher joke. All right, let's flip this card here. I'm going to turn it over. Oh, 2. And now we certainly know what this last card is. Is a 2 and 9. Awesome. Anybody get it? I'm not going to scroll back in the chat. Anyone get that on their first guess? Yeah, fun math routine for warming up. I've done this in 7th grade. Kids have a good time with it. I've done it with my 3rd grade daughter. She has a good time with it, right? I think like we as adults were having a good time with it. Like a nice 5-minute warm up in class. I want to show you where you can get this. I'm just going to go to Mathagon. I'm going to leave this here. I'm on my teacher dashboard, but if you just go to mathagon.org, I'm logged in as a teacher. I have a teacher account. But if you on your own go to mathagon.org/tasks, I'll put that in the chat as well. Mathagon.org/tasks is our task page that has all these puzzles, activities, and lesson plans. And the 8th one here is called Class Openers and Math Talks. And so this is a growing list of class openers and math talks that you could do at any point in class. That might take 5 or 10 minutes or so. And this first one that we just did is what are the 2 cards. And so you can click on this and take the cards and stack them up and have a good time with what are the 2 cards. And I think what that example shows is what I really like about PolyPad is all the tile types can work on the same canvas at once. So on that task here, I'll just open it up again. A number line, a balance scale, the playing cards, the dice, and this thing here was actually a fraction bar that I could extend where the labels on the fraction bar were turned off, right? So it didn't really seem like a fraction bar. I was using this as a way to to help the numbers that we knew it couldn't be. So a fun opener. Thanks for participating in it. I want to share with you another task. We'll spend a little bit more time on this one. I'm going to go to a blank PolyPad. You're welcome to do this with me. We have a Google slide deck that if you want to put in a picture or a link of your work as you're following along with me, great. Obviously, whatever you're most comfortable with. There are sometimes in webinars I like to sit back and take it all in. There are sometimes I like to try to do it on my device at the same time. Whatever obviously is best for you as a learner, go for it. No need to share at the end if you're just taking it all in. But if you want to, you can go to a blank PolyPad just at mathagon.org/polypad. I'll put that link in the chat as well. If you don't have a Mathagon account, you don't need one. Students don't need an account to do everything I'm about to do right now. If you want to save your work later on, you have to have an account. But all of these tools are open and free for everyone. Again, I don't think I mentioned it. Mathagon is free for all teachers and students. So everything I'm doing tonight and sharing, Karina, yes, cheer. I know I love being part of an organization that just makes all these tools free for teachers and students. It's a big part of our commitment at Mathagon. So that's super exciting. I'm going to talk about my journey as a 7th grade math teacher teaching the area of a circle. And so I know I've been teaching math for 22 years or so. I started in the fall of '99. And when I first started teaching the area of a circle, I gave them the formula. We wrote it on the board, pi r squared. They wrote it down, made kids memorize it. I probably quizzed them on, do they know the formula? And then I gave them all sorts of numbers to find the area of a circle. Gave radiuses that maybe were fractions or decimals to make it really hard. And a good one, Teresa. And I maybe sometimes gave them the diameter to make it confusing, or sometimes gave them the circumference. But it was just all like numerical manipulation. And they really had no idea as to why it was pi r squared. And to be honest, when I started as a 23-year-old math teacher, I don't think I knew where the formula came from. I just knew it was pi r squared. So as I got more experienced as a teacher, I was like, why does this formula work? I was curious for myself. So I went and I explored it more. And I eventually came to the idea that you've probably seen before. You can cut the circle into the pieces of a pizza and rearrange it into a parallelogram to try to find the area. And I thought that was really cool. So I made a whole story for my students how I bought a pizza, right? And I wanted to heat it up into the oven, but the box wouldn't fit. So I took the pieces and put them on a baking sheet. And I was doing all the work on the board. I was hamming up the story. They were laughing. I kind of had them write it down. And I thought I was getting them to understand where the formula came from. But really, it was just me telling a fun story. And the long-term understanding of where the formula came from wasn't there. So fast forward a little bit more, I tried to find some good visuals of that happening because my drawing on the board wasn't that convincing for students. And there's a good one on Mathagon that I'm going to share. These are on our courses. I'll put this link in the chat. You don't need to go to it because I'm just going to show you what I'm talking about, but if you want to get this link later, here's a really cool here's a visual of this happening, right? There's a slider here. I can move the pieces back and forth. I can change the number of pieces. So it's more pieces, so it's closer and closer to parallelogram. Really nice visual. I like that there's a slider. I like that kids can kind of control the slider on themselves. But again, it's they're watching it happen. It kind of feels like they're engaging with it because they're doing the slider, but it's them sort of being like, oh, cool animation, right? That some person made. What I want to show you is how I've used the tools on Polypad to have students do this for themselves. And that to me, I think is the real power of virtual tools like these is it goes from watching the teacher do something or watching an animation to students doing it themselves. And when students do it themselves, we know there's greater long-term understanding of what's happening. And there are times that a physical tool is better, right? Sometimes we actually want them to have the physical tool to do it themselves. Here's an example where I think the virtual tool adds great connections in their brain. So if you want to do this with me, great. If you just want to sit back and check it out, whatever is best for you. But I'm going to go to the fractions. I want to build a circle. And this would be after exploring area of parallelograms and triangles with students. And our approach is, like many teachers, take the parallelogram and cut something off and make it a rectangle, right? And take the triangle and double it or cut it to make a parallelogram. And eventually it all comes back to the area of a rectangle. So this would be after doing a lot of that in school. I'm going to go to the fraction circles, and I'm going to build a circle out of sixths. You can see there are no labels on the fraction circles right now. Under settings here, I can toggle back and forth between whether I want to have the labels on the fractions or not. So I don't want the labels on the fractions right now. I'm going to do the sixths. I'm going to build a circle with 6. Oops. Let me just zoom in a little bit. You could try it with a different fraction. You could do it with 6, whatever provides you joy as a learner. I'm going to hide the number labels. Now I'm going to copy this tile. There's a copy option at the bottom. You can also just use C, the button C, as a shortcut to copy. You don't need to do Command C. I'm just going to tap C on my keyboard, and I'm going to stack 6 of them on top of each other, because I find when I stack them on top of each other, it's really fun to make a circle. Because now I can take this one on top, and I can use the black tab just to kind of spin it around, and it snaps into place really nicely. So there's smart kind of snapping of these. There's 3 of them, 4 of them. Oops. There we go. 5 of them. And the 6th one. So I've made a circle. Here's my pizza, and I would, in school, it would depend whether I would show this to students first and kind of do one example together as I'm doing now, or if they had gotten really comfortable with the Polypad tools and we've really established this idea of you can find area by making things into other shapes that we know, I might just say, go make a fraction circle and go find the area and just let them explore and discover and play. I'm going to share some ideas now about how we could do this. I'm going to change the color here. So let's make this, more like a cheesy color. There's our pizza. And I might start by saying, all right, here is a polygon. This has area of 1. Put in the chat right now how many squares you think it'll take to fill up this circle. So I'm telling you as a default that on Polypad, this blue square has an area of 1. Just give me a best guess of a visual. What do you think the area of the circle is in terms of these blue squares? Karina says 15. Teresa says 9. Awesome, 9, right? And in class, I might have students kind of do this so they can make their own estimate, right? About 10 or 11. All right, seems like some good guesses as to what this might be. So let me get these all out of the way. I'm doing Command Z to undo on my polypad, and I'll just move that square out of the way. Good guesses, everyone. Let's see. So now I'm going to take this, I'm going to copy one, and again, I would have students kind of exploring this more on their own than I'm doing right now, and I'm going to take this one and spin it over to make it a, like two pieces here. I'll copy and move this around, so I've made it into a parallelogram. So there's the pizza shaped as a parallelogram. And now there's this tool over here that is the custom polygon on Polypad. So all of these, I just put a septagon on the screen. You can spin those, you can move them, you can cut them. You aren't able to change the size of those except for the custom polygon. So I'm going to use this one that's the custom polygon. And right now it's a pentagon. You can see there are 5 vertices. If I click on a vertex, it's going to go away. So I want to make a parallelogram on top of my pizza. So I'm going to click on this one to make it a quadrilateral. And I'm going to put it on top of this pizza, and you can see it kind of snaps into place. So I'll make it in to make a parallelogram. And again, if you're watching me, that's awesome, but I want you to think about if students were doing this, right? They're really connecting to the idea that they took the pieces and moved them around to make a parallelogram, and now we're drawing a parallelogram on top of this. I like my parallelogram, seems pretty good, so I'm going to fix the vertices down here. When I fix the vertices, that locks the shape in place. So I'm going to fix the vertices, I'll copy it, and now I want to slice this off to make it into a rectangle. Again, this would be after students have really developed that idea. I want to show off our measuring tool. I'm going to put a ruler on the screen just so I can make sure I'm cutting at a 90-degree angle. This snaps into place, and it snaps at a 90-degree angle as well. So I know I'm cutting at a 90-degree angle. I'll go to the cut tool, and I can just click and drag to cut that polygon. The cut tool is one of my favorite tools on Polypad. So let me just show that again. I've put the ruler in place. I've clicked on the parallelogram, and one of the options at the bottom is cut. So I'll go to cut, and I'm going to cut this piece off right. Oh, I think I missed it. I don't think I clicked cut. Sorry, there we go. Now I have the cut option. And now I can take this triangle and actually move it over, do it over there, right? The cut tool is a game changer. My students last year in 6th grade, when we were doing the area of parallelograms, the conceptual understanding that they developed by actually cutting it themselves and dragging it over was profound. I've done it for years where I had them draw it on graph paper and they cut off the little triangle and then they taped it over here. And the actual scissors and tape and glue stick and graph paper that I was doing it in person years ago got in the way of their understanding. The task became more like a craft project than actually focusing on the math. Here, it was so easy for them to cut and move it over that they did it themselves lots of times and got the practice that their brains needed to internalize that idea. So here's my rectangle. There's also a join tool here. So now I have these two pieces. I'm going to join them together. I'm going to select both and click join at the bottom. So I've joined them together, and there's my rectangle. So I might have a conversation now. You can tell me in the chat, is this area of the rectangle more or less than the pizza, or the same, do you think? What's your prediction? Do you think that rectangle is going to be more or less than the pizza? I think we know this as math educators, but a good conversation with students, right? Why is it going to be less than the pizza? We can see those pieces of crust that are sticking out. So this might give us a good approximation of the area, but not exact. So now at the bottom here, I've chosen a line tool, and I'm going to draw lines around the rectangle. Let me just escape from this tool for a second. There's a few ways on Polypad to draw lines. The pen tool has a ruler, and the ruler can draw a straight line. But I'm actually going to use the construction tools right now, because when you use the construction tools, Polypad can find the area of that shape. So I'm on the construction tools at the bottom. I choose a line, and I'm going to draw a line around the rectangle. I have to make sure when I start my line at the bottom that it's on top of the vertex of the line that I just drew. So you can see as I do that, there's a gray circle that comes on top of it. So I'll draw this rectangle, and there we go, I've made the rectangle. I'm now going to move the green rectangle out of the way just so I can see this big, nice rectangle that I've drawn. And if I click and drag over the whole rectangle, I've selected all the sides of that. And in the construction tools, there are some options that appear at the bottom. I found that I know there's a lot of folks on the screen that I've seen engaging with Polypad on Twitter, which is awesome. Some of the features that I find people aren't aware of because it's not totally obvious is the features in the construction tool. So I could find like the centroid of this rectangle. I don't really want to do that right now, but on these three dots, if I click on these three dots, it shows me the area, perimeter, and the sum of the internal angles. So on Polypad, this rectangle has an area of 10.4. So you can see those are the three dots. I clicked and dragged over the whole rectangle. Yeah, a lot of connections to Sketchpad. We are not even close to the number of features on Sketchpad, but for a simple task like this, it's nice to be able to have Polypad calculate the area. So if I were doing this in school, I might take this square and ask students to fill it in to show that it's about 10.4. I could use the cut tool. I'm going to skip that right now, but what we found here is the area of this is 10.4 square units, right? And then we can compare that to the area of the circle, because also in the construction tool, there's a circle option. So I'm going to make a circle, and I'm going to start right in the center. It snaps in place, and I click and drag to make a circle, and it snaps in place at the end as well. So I could really easily put a circle on top of my fraction bar. I'll slide this circle down here, and anyone want to enter a prediction of the area of that circle in the chat? You all said it's more than 10.4, right? So how much more? Well, a couple of you said it's all in class, right? Good conversation here, right? How much bigger do we think it's going to be? I'll do the big reveal. The area of this circle is 12.6. So this area was 12.6 square units. And then again, if I was doing this in school, maybe I would do this whole example once, as I did for all of you, and then I might tell students, go do one on your own. That does a little bit of like watch and copy what I did. So with my students who have kind of developed a good understanding of Polypad, by the time they get to this point in the lesson, I might just say, make a circle and go, right? And go and talk to each other. How did you take the circle and make it into a parallelogram? What tools did you use on Polypad to help you find the area? So all sorts of fun things. And then we would talk about why are we so far off, right? Because we had all these crusts like sticking out, right? Anyone have a suggestion they want to put in the chat as to what we could do on the next circle to make it make the area of the parallelogram closer to the area of the circle? Let's see what's in the chat here. Molly did it with fourths and the rectangle was 8. Yeah, so I bet, Molly, your rounded off pieces were much bigger. Molly, if you have a Polypad account, which I'm guessing you do, if you want to save your Polypad canvas and put it in the chat, I'd love to just share that if you're comfortable. There was a suggestion to go with smaller fraction pieces, make more pizza. That sounds fun. There was a suggestion to move the parallelogram at the bottom, maybe go to 12ths, all sorts of great ideas, right? And so what I've done in the interest of a webinar, I made one with 12ths. That was a good idea. And so I think that's in my geometry webinar folder. So as a teacher, you can save Polypads and make folders. So these are all the folders in my Polypad account. As a student too, any user of Polypad can do this. So here is my example. Ooh, let's look at Molly's first. All right. Thanks, Molly, for being willing to share that. Awesome. Look at that one, right? And what an easy way for students to share their work with the class. Really big pieces of crusts, right? And so that would make sense that the area of that rectangle was 8. Is that what you said, Molly? 8. Yeah, awesome, right? And so here's one that I made with 12 pieces. Oh, I think I was on the way to pulling that up. Let me go to my webinar. And here's one with 12 pieces. Yeah, so this one with 12 pieces, the area of the rectangle was 12, and the area of the circle was 12.6. Awesome. I see a question in the chat about how you got the link. So if you have a Mathurdays account and you click save here, then it'll save that canvas to your account. And then if you click on that link under sharing, it'll copy it to your clipboard, and then you can just paste it. You could also just go up to the URL and copy paste as well. If anyone has other links that they want to share, that'd be great. And then what I would really encourage with students is make really big circles. So let me just like show you how I could use the tools to make a really big circle, because maybe that only works when the circle matches up with the fraction bar, right? Like we need to have conversations about, does this work with other size circles? So here's a bigger circle. We could find the area of that bigger circle is 100.3, and then students could take the protractor tool if they wanted to. I'll take the protractor tool and put it on, and I could use that, and the line tool, see how it snaps in place, so it's right on the circle. I can use the line tool. Ooh, Lisa has a good message in the chat I want to read after I draw these lines in. I'm using the protractor tool to try to get, all of these lines in the right spot. I could go to 45 here and draw a line through. And then what's cool, let me just share this and then I'll go check out the chat. I can get the protractor out of the way here. I can get the protractor out of the way and go to the custom polygon and do the exact same thing by making the correct size pieces of the pizza. Now you're going to say that is not close. That is really not a good approximation of the piece of pizza. But just like I can click on a vertex to get rid of it, if I go to the polygon and I click on this line, I can add a vertex. So I can click here, add a vertex, and drag it on top of the circle so it snaps into place. And I can do this a bunch of times so I can get a shape actually that really closely will match up to 1/8 of the circle. And if I feel like that looks pretty good, which it does, not bad, I can fix the vertices so it's locked, and then I could take this and spin it around and copy paste it a whole bunch of times. And then students are off and running doing their whole thing. The last thing to show here on this task is I did a version of this in school last year, and then we took this rectangle and said, okay, how does this rectangle compare to the circle? And on this example, I did, I talked about it was like half pepperoni, half cheese or something. And I did the pepperoni, cheese. So they see that the base of the rectangle is half of the crust, half of the circumference. So you can add a text box here. Oh, I didn't mean to change that color. Let me go text. I can add text that this is half of circumference. And then I can take the rectangle and put it in the circle for students to see really clearly that. And what I really liked, I had a couple students all year who anytime they did the formula for the area of a circle, they used the formula half circumference times radius. Even though we took that formula in class and we worked with it algebraically and we talked about how mathematicians don't love formulas in formulas, so this is kind of like not the most simplified formula, but they used it because their picture in their head of this rectangle was half circumference times radius, which I thought was such a good testament to the power of this tool, that's what they remembered. Even though on my board in school, I had written area of circle equals pi r squared, and I think I even wrote it on like assessments for them, they still went back to half circumference times radius, because that's the picture they had in their head of this mathematics. Yeah, it was so cool. All right, I want to go back to the chat here. Lisa's sharing, you used the area formula on Monday and worked on determining the formula. Awesome. We took cupcake liners, ended up with 8s, glued them down. Oh, and cutting up the cupcake liners. That's really cool. Awesome. Thanks for sharing that. Great task. Cool. All right. So that's just a quick overview of the tools in geometry. I actually want to do one more of the class openers with you. So I'm going to go to a blank canvas, and I'm going to put 4 squares on the canvas. And this is a hard thing to describe in the chat, but I want you to think about when I do 4 here. Let me zoom in once I got all 4. Here's 4. As I select all of them, one of the options that comes up at the bottom is a fold net option. What do you think this shape will make? So if you picture this as a net, like a net of a 3D object, and I click fold, you can try this on your own. What do you think is going to happen as this folds together? Is it going to make a shape or not? And so one of the really great features is the ability to do this. I'm going to click fold net, zoop, and it's a cube with no top or bottom. All right. And so part of the challenge here is to figure out how the algorithm on PolyPad is going to fold this. I saw a few comments in the chat. There's one that said a box without a top or bottom. Some would be an open 3D shape, doesn't have enough faces to close it. And so part of it is like to try to figure out what we've done on PolyPad, and by we I mean the coders and the engineers who have figured out how to make these fold. So that makes an open box here. I'm going to click the unfold button, and I'm going to add a couple more. Zoom often makes PolyPad act a little wonky, but here's 6, and when I fold 6, some of your predictions were correct. They're going to fold on top of each other. So here with 6, as I unfold it, you can see it doesn't stop here, but those two overlap. but I can get it to stop there by adding a hexagon on and folding this one. Watch it. Oh, first I have to unfold the blue, unfold this one, and then put all these together, fold net, and there's the prism. And this, I find that a lot of my students, myself included, have a hard time visualizing what happens when you fold a 2D shape. And again, I've done so many activities over the years in school where kids cut things out and they tape them together and they try to fold them together. There's those awesome ones with string. Maybe you've seen those out on Twitter where you pull the string on the paper taped together and it comes together. Those are cool. I have a really hard time building them. Now that's kind of a fun task to build them. But here, kids can actually build something on their own and try to fold it together and see what happens. I want to go to our task page. So I'm going to go back to mathagon.org/tasks. and ask you to think about a task all together. I'm going to go back to the class openers in Math Talks and open the one called folding nets. I want you to, without folding them, can you predict in the chat what any one of these are going to do? What do you think they're going to make? So you can use the colors maybe to describe them. What do you think the blue one's going to do? What do you think the orange one's going to do? Green, red, purple, and pink. When I select them and fold, any predictions as to what might happen? I'll give us a minute to explore those and kind of think. What do you think would happen as I fold these? Ooh, Teresa's got a good challenge, make a 3D solve using a heptagon. You should go take a break and explore that after this one. People can share. Let's what do you think is going to fold? Anyone have a prediction? Feel free to just drop it in the chat. You think the blue one? Karina says the red one's going to make a cube. Awesome. This red one down here. That's the one my brain is seeing as red. I see this one as orange. Peach is a cereal box with an extra tab to glue in. Cool. I can picture that. Blue orange will make a normal cube. Green will have an overlapping top and bottom. Awesome. How about the purple one? What do you think is going to happen with the purple one? You can go here and do it on your own, right? A fun task here would just be to do like make a cube and then have students say, go find all of the ones that can make a cube. We have a task there just on exploring all the nets of a cube. Purple makes my brain hurt. Me too, Teresa. I have gotten better over the past couple months. Now that we've had these tools out there and I've played with them, just on my own, playing with all the nets that are out there, like, not surprising, I've gotten better. Let's do it here. So this one, people said makes a cube. Let's see. Zoop. Yep. So that one makes a cube. There we go. Right? This orange one. That'll make a cube. The green one, it kind of depends on what rules that Polypad has in place, but on this green one, as you've done a few of them, it makes like half of a box. Excuse me. And I like that like students can spin it and actually like unfold it at any angle they want to try to think about what's going to happen there. And that might help you adjust your thinking on this kind of reddish one where it's the same idea just with that other piece in there. So that's pretty cool. I'll save the purple one for the end here. I think I saw someone, the left corner in the purple crumples up, right? It kind of like all like implodes on itself kind of, right? So we'll hold that one off and see what happens. On the orange one, yeah, I thought, Karina, that my red and orange, we had different colors here. Here's a cube with the tab on the cereal box. I think I saw that in the chat. There's a tab that like, you know, overlaps itself. And I think this is a good conversation for students to have that like oftentimes in class, we'll talk about how that doesn't make a cube, right? But almost every box that comes to my house has some cardboard that does overlap. Right, we see that in cereal boxes. We see that in Amazon packages, and right. And so, like to say that that doesn't fold to something is almost doing kids a disservice to what we often see in cardboard boxes. Right, to say, okay, what we're going to define is the net of a cube is the smallest pieces, you know, that can make a cube. But if you need a box where the bottom is doubly like reinforced, how can you go make that? And I think it's great here that like students can explore that. Okay, what kind of net do I need if I want the bottom to be doubly strong or the top or the sides, wherever, right? So I think that like values their thinking and their experiences that sometimes cardboard does overlap. When I do wrapping paper, right? How many times have I done like the really silly math question of like, I'm wrapping something in school and I don't want any wrapping paper to overlap. How much do I need? Well, we all overlap wrapping paper when we wrap presents, right? So that can happen here. All right, the purple one. Are we ready? Lisa said the bottom left corner will crumple up. And there's no great visual of it, but I click fold net And the message at the top here is this is not a valley polyhedron net. It does not fold. Kind of anticlimactic. I know we were expecting some like implosion. Maybe we should add a sound effect to this or something on Polypad, but it doesn't fold, right? And there's something, as Lisa identified, that's happening at the bottom corner, right? Those four squares coming together make it not being able to fold. And so I think that's a great conversation for kids. I just want to share that we have a number of nets that are like pre-made on Polypad. So you can take a dodecahedron and put it on the canvas and just have students explore that. Those are all the Platonic solids. How beautiful is that? So fun to play with. And then under File, all the way at the bottom under File, this is here for anyone, whether you have an account or not. So these are all my Polypads. But under File, all the way at the bottom, if you open the folder in Geometry, there are nets of all the Archimedean solids, which are just like fun to go play with. I have a poster of these in my room. Kids are just fascinated by the vocab words yet at this point, and they like going to talk about them. I can't wait until the day where I'm like, this one that you tried to like figure out how to say it, we can actually unfold it now, right? Like how cool is that for students to go and do? I think at first what I might do in school is show them the poster and how to build nets and say, go try to build some, right? It's much more fun to go try to build them on their own. Then go from there. That's the quick overview of geometry. I want to get into balance scale and algebra stuff and some probability stuff, but I'd love to just pause for a moment, see if anyone has any questions. I see in the chat, can you use the cube net and stretch it to make a rectangular prism? Let me show you how I would make a rectangular prism. You can't take the cube and stretch it, but what I've done is I've turned on a grid background. So I'll turn on a grid background and I will use a custom polygon to make a rectangle. So I can have this, and I turned on the grid background so I can be sure that it is a rectangle. So I missed a little bit there, but let me make a rectangle, right? So now I have a rectangle. I can fix the vertices, and then I could decide like what kind of prism that I want to make. I think that's a octagon, so I could take this rectangle and copy and paste it a whole bunch of times. I could take these two and copy and spin it. And again, this would be something for students to do, not just to watch me do it, right? Hopefully you might be doing some playing as I'm doing it. And then what's cool, I think, even at this point, you can hit fold just to get a sense of whether you're on the right track, right? I think it's really nice for students to build something and get like immediate feedback. Oh yeah, I'm doing good so far, or even stop here. That's kind of a fun shape, right? And like, there's a lot of awesome programs out there that allow students to build something and fold it. I think this is great that at this point you can stop and like unfold anytime you want. So hope that answers your question, Karina. Cool. All right, let's move on to geometry and play around with the balance scales a little bit. I want to go to the task page. You can go there with me if you like. Let's go to mathagon.org/tasks. And the one we're going to explore is the balance scale polypads. So I'm going to click on balance scale polypads. This is a link to any number of pre-made polypads that take advantage of the balance scale. And so there's a range of things that, thank you so much, Teresa. There's a range of activities here, just as examples of how I think the balance scale can be really valuable for students. I want to share one at the elementary level. I know this was dubbed as middle school, but I'll do an elementary, middle school, and high school way of how students might engage with the balance scale here. You can see on this one there's like the answer at the bottom. This is because it's made in my teacher account. So I'm going to get this link. I'm going to put it in the chat in case you weren't there on the page. But I'm going to open it in a incognito browser and paste the link, and imagine I was a student doing this. So I could guess and check. Maybe I think it's 6. It's not, right? I get like a red X. I gave this to my 3rd grader last spring, so she was a 2nd grader at the time, and she was comfortable with Polypad at this point. So she went to the number cards and said, I think it's 5, just was her first guess. So she took 5 and she put 5s on top of itself 4 times, and she saw that was 20. And even just the act of doing that without her really thinking about it, she was getting like good practice of the multiples of 5, right? She's counting by 5. And she saw that was too small. I think then she tried 6 and that was too small. And eventually she got to 8 and put 4 8s on top of each other and saw that got to 32. And then she was excited that she found the answer. And then she actually went and put 8 and copied it on the scale 3 times and it was done, right? And she could put those together and say that that is 24. And really easy to make these and then just go have kids play. You can put dice on these as I shared before. You can put cards. And then when you get the right answer, you get a nice check and confetti comes down on the screen, which is always kind of fun. I've had students go back to activities that we started in class just to get the confetti. And I was like, you don't need to finish this. Like, but great. That's awesome. But let me go to one more at the middle school level. And I'd love your help on thinking about how we could solve this one together. So I'm going to go to linear equation number 5. So let's just jump ahead in our mathematical development a tad and go to middle school. And certainly I want students at some point to like abstract their ideas of how to balance scales and eliminate numbers and get the variable by itself. But just to play with scales for a while with the algebra tiles is a great way to get their thinking started. Anyone want to suggest something in the chat for me to do on this balance scale to try to balance it out? I know there are some of us are more familiar with the tile types than others and the options. Move the X tiles to create a 0 pair. Yeah, awesome, cool. Thanks, Karina. I'm going to move the X tiles to create a 0 pair. I move them over here to make a 0 pair. Ooh, but the scale got unbalanced. I'm not happy with that. Maybe you're happy with that. I don't know. But I want to keep the scales balanced, right? So I'm going to undo that. I liked your idea. Well, that stayed a 0 pair for some reason on my screen. Oh, there we go. I think my polypad's going to catch up with me a second. Can we do something? Let's stick with the 0 pair for a second. And let's, Karina, can I stick with you? Do you want to try to adjust that a little bit? So I just moved the X's. Now there are some programs out there, I think on Graspable Math, which is awesome. I've loved Graspable Math. When you move X's from one side to the other, it actually changes them for you, right? Is that right, Karina? I see you, right? So maybe understandably, what you were expecting was when I moved these over here for those to change to positive X's, right? And it didn't. So our balance scale, if you move a tile around, it's not going to automatically change things for the students. And I think there's pros and cons of that, right? We could spend probably this whole webinar debating the pros and cons of whether that should change or not. So do you want to suggest, I think I see things, add 2 X's on both sides. Cool. So I'm going to go to the algebra tiles. And I'll take an X tile and an X tile. And let's see if this keeps the scale balanced. I'll put 2 of them over here and 2 of them over here. Now I'm biased on this tool, obviously, because I'm part of the team that helped develop it. But I like that it doesn't automatically change things for students, right? That they have to okay, what do I need to do to keep this balanced? First, I could put 2 X's on each side, and then I put those on top of each other, and there's the 0 pair. And I also really like that students see the 0 pair. So now to get rid of it, I have to actively decide whether it's fine to keep it there. I could just keep it there, or I could take it off the scale and see that it stays balanced when I get rid of a 0 pair. I saw someone put in the chat, add 48 to each side. So I'll go to the number tiles. I could actually use the number frames to add 48 with the Cuisenaire rods and number frames. I'm going to go to the number cards and type in the number 48. And I'll add that here. That's not going to keep it balanced because we got to do it to both sides, right? And then we can put that on top of each other. And again, the same thing, it makes a 0 pair, which I think is really nice for students to say, okay, I'm trying to make zeros all over the place, right? And there's 70. Now, in my perfect world, I would only have students use the calculator features on Polypad, right? So there's some students obviously would be comfortable with dividing by doing 70 divided by 5, but I also want to take this opportunity to show you the prime factor circles on Polypad because I think it's a really cool built-in calculator for kids. So these prime factor circles, if you've not seen them on Polypad, they obviously are the ones from Dan Finkel's game Prime Climb and the Math for Love multiplication flashcards that are appropriately getting lots of good PR and excitement on Twitter. Those are awesome flashcards. I can take the number 70, and so these are made in collaboration with Dan Finkel, obviously. I can take 70 as a prime factor circle, and if you've seen the prime factor circles, you can see that is the blue is 5, purple is 7, and the orange is 2. 2 times 5 times 7. But what's really cool is I'm gonna copy 70 just to keep it there. I can pull these apart. So they are like engaging and dynamic prime factor circles. So I can pull this 5 out, which is showing me that 70 is 5 times 14. Right? So as a calculator, right, I want to divide it by 5 and say, 70 is 14 times 5. So I can put the 14 here and then go like that. And there we have solved that equation, which I think is really cool. If, just as another feature, I could build the number 70 in the number tiles. Let me just do this quick: 10, 20, 30, 40, 50, 60, 70. There's 70. I can select all of the number tiles and merge them together. So that's a grid of 70 tiles. And this tab, I can click and drag to make a rectangular arrangement of those 70 tiles. And if I turn on a grid background, I can see that is 5 times 14, which I think is a really nice visual as well. So I think that idea of like, you don't need a calculator, because really almost any calculation that you want to do, you can use the tools on Polygon to help you. So one last balance scale that I would like to share. Let's go all the way to a quadratic equation. Here is quadratic number 2. And I'll just do this quick because I also want to show another cool use of the prime factor circle. Let's go here. There is an option at the bottom when you click on an algebra tile. You can negate it. So if I copy this and hit negate, it'll make one that is an x squared, just for like an ease of use. So there's the 0 pair that I can get off the screen. I'll take 32. So, you know, I could do this move where I take the 32 and I put it over here, but I know it's not balanced because I was just moving 32, but I can negate it, and then it stays balanced. And so there's the 588. And now I think this is really cool. I just want to show the prime factor circle again, because I could take 588 and say, all right, what do I need to do? I need to pull out a 3. So one of those x squareds is 196, which hopefully will balance the scale. And then I think these prime factor circles can be used really wonderfully to think about the square of a number, like what times itself is 196. And I could take an x tile here and show that we're actually trying to find the number that when you multiply by itself, it makes an x squared. I've obviously unbalanced the scale here just to demonstrate this. And so here we're trying to split this 196 into something times itself to get to 196. Oh, I did it the wrong way, right? I want to do something times itself, right? So I need to put like an orange one over here and a purple one over here. So now I just did it as 14 times 14. And I can see that one of those x's is a 14, which is pretty cool. And so I think as a way to kind of build that idea of how can you tell if a number is a perfect square by its prime factorization, right? What a fun use of these things to say, is 1,000 a perfect square? Kind of feels like it should be, right? Because it's a number with a lot of zeros and a lot of factors, but can you take that number and split it up into the same like prime factor circles in each pair? Right? I could say, all right, I'll put an orange one and a blue one over here, and an orange one and a blue one over here, and an orange one and oh no, right? Not a perfect square, right? Perfect cube, right? But as a way to begin just to pull factors apart and put them together, I've had great success doing like greatest common factor, least common multiple, all sorts of stuff here, which is really cool. Yeah, you can take any prime climb number, right? You can type them in and you can go from there. It is 12:50. I have talked way too long. I had other things I wanted to do in the chat. But I would love just to stop here and say, you know, I was going to show you some of the probability tools. We have coins, dice, and spinners, which are awesome. We've added charts and statistics, which are super fun. Playing cards you saw, polyhedral dice. One last plug or place to get more information, and then I'll open it up and talk about anything people want to talk about. On our tab, if you go to mathagon.org/teachers, yes, you can add text on the spinner. I will show you that in a minute. Mathagon.org/teachers. I've done a number of webinars that are more of like explaining about the tools. I want to do a little bit more this afternoon of having you engage in the chat and make predictions and do like one task with the circle. But under events and webinars are all sorts of past webinars that we've done on specific topics that you could go explore. There are a number of tutorial videos, multiplication by heart tutorials, and then our task page has over 100 lesson plans, puzzles, games, student explorations that are super fun. I know I've seen Molly playing with the puzzle of the day at home, the actual puzzle of the day, which I have at home as well. But there is a polypad version of the puzzle of the day, which if you have not explored, puzzle a day, where did it go? It's up here somewhere. There it is, a puzzle a day. You could go explore the polypad version of. And then two last things to show. On polypad, there's a number of tutorials. So if you're trying to like explore more about polypad and there's something that's not working, at the very bottom here is tutorials. It takes you to a page, like an overview page on polypad in general, and then a specific page on using all of the tools. So how to use all the geometry tools, all the probability tools, and so on. And then the last plug I'll give is we have a guest speaker series that we are hosting free for everyone, of course, for this school year on that we're hosting with an awesome array of math educators in the world, starting this Wednesday with James Tanton, and then Simon Singh, Sunil Singh, no relation, Mary Kemper, Maria Del Rosario Zavala, Dan Finkel, Katronia Harrison, and Jennifer Sugg, who I learned today is a colleague of Teresa, which is pretty cool. So that's at mathagon.org/events. Again, free for like, all free, right? No sales pitch going on here. But thank you for allowing me to plug those things a little bit. So I'm happy to answer any questions. If there's a specific task that you're trying to think about how you could use polypad for, feel free to put it in the chat. We're a nice small group. If anyone wants to unmute and ask a question, you can either raise hand or even just like unmute and chime in if you like. Let me just see if there's anything that I missed in the chat. Oh, spinners, can you add text? Sure, let me just show an example of that. Yeah, that would be, there's also in the tutorial page, it shows how to do that, just in case this goes quick and is confusing. But here's a spinner, and I will get my cursor in the right spot so I can zoom in a little bit. And then you could add an image, you could add text, you could add a number, a letter, but I'll go to the text box and I'll just say A here, and then you can spin it. Now, if this is something that you want students to use and you don't want them to like mess up the spinner, I could take this. Now, first, there is the option to get on the A. So if you turn on under settings, show advanced options. So I have show advanced options checked. And when you do that, a gear appears at the bottom. And so a text box automatically stays on top of any tile type. So this text box is always on top. If I want to make sure students don't like mess up that box by mistake, I can lock the tile. And you can see now when I click on the A, I can't. Now it's affixed to that spinner. What we don't have the option yet to do, which is on the list, is to group tiles together. So you can see here, I move the spinner, the A doesn't go with it. But what you could do on the spinner is lock the position of the spinner. So now I can't move the spinner. It's locked in that spot on the canvas, but I still can spin it. A locked tile, I couldn't even spin. So if this spinner were part of an activity that you were building with students and you wanted to make sure they didn't mess up the spinner or move the text box, you can lock the text box and then lock the spinner. Now, if students are really motivated to mess up the polypad, under settings, you can show and unlock all tiles. So students could do that. That isn't something yet that we have a feature to turn it off for students. So now I show and I unlock, and then I could unlock the position of the spinner. So there are some workarounds if students are really motivated to mess you up, they could, but that's an option out there. Let's not show that. Absolutely. Yeah. Special ed, algebra. Awesome. Great. Thank you. MATHurdays folks want to do a task on prime composite numbers. Does Mathagon already have one? We have a few on our task page. I wouldn't say it's like a complete task yet on prime and composite numbers. So I'd love to see what you come up with. Obviously, the prime factor circles go great with prime composite numbers. I will share. There aren't any titles with prime and composite numbers, but can I share a few tools that might be helpful? One of my new favorite tools that hasn't got a lot of like press yet, which is a goal, is these. It's a dot arrangement. So obviously there are a number of these tile types that can help think about a prime and composite number. I could take the number 12, right, and put it on the screen here and try to arrange the 12 into a variety of rectangles, right? And so how many rectangles can you make with all the bunch? But if we do like 11, I think that's just a nice introduction to prime and composite numbers, right? Just like actually trying to make these into rectangular arrays, and like what numbers can you make lots of them and what numbers can you not make lots of them for? And then under a dot arrangement, I'll put out 12 on the canvas here. And you can see that right now is, that shows 12 in a variety of ways, and I can combine factors, I can split factors, I can reorder them in all sorts of ways. I don't have time to get into it, but there's a great video in the tutorial page about what's actually happening when you like reorder and combine and split. That is super fun for kids to play with, but they could explore like what numbers does that not work for. So if I put in a number like 27, oh yeah, there's all sorts of ways that I could, well, there are some ways I could do it on 27, but what kind of numbers that you type in are there really not any options for, and like why are those numbers not having any options? So that could be a fun thing for kids to explore. But no super developed pre-made like tasks and lesson plans yet, but we should do that. Did I miss any other questions? I think that was it. The mess up the polypad kiddos are my favorite. Yes, absolutely. They're trying to go debug the system a whole day or 10 to play on polypad. Yeah, I was sharing with Teresa that I've been finding on these webinars, as we add more tile types, there's just more and more to show, and there isn't as much time to get into all the features. So I wanted to pick a couple tasks that I think show a couple of the tools in use at the same time. And I really like that one on the area of the circle where it shows the fractions and the custom polygon and the measuring tool and the cut and the ruler. I think that's a good one. And the last thing that I'll share is I think we know it's so important for kids to visualize numbers in lots of different ways. And so I think being able to use all the tile types on the balance scale at once helps them really develop that sense of like equality and different number representation. There's one on the balance scale page that I didn't share that I think really shows a good example of the value of having kids explore with all different ways to represent numbers. So here's a number of balance scales that are not balanced, and the instructions would just be go balance them any way you want, right? They could add the number frames or the number tiles or the number cards or the dots and just balance the scales, and then to have students like save their work and then share it with the class and say, how did you balance it? What did you do to get those balance out? I think is helpful for kids. Awesome. Energizer Bunny. Well, I like truly, I've had so much fun like doing this as part of my teaching, and I'm really a believer in the tool that it's fun for me to talk about. And I sometimes get carried away and talk too much and don't allow for too much in the chat. So I hope, even though this might not have been as interactive as you might have been thinking coming in, I hope there was some good, some good value, ideas shared. I will wrap it up there. Happily take any more questions, turn it over to Teresa. But thank you all for coming. It was a great way to spend time on my Saturday afternoon. I don't know what time it is for everyone out there in the world. But thanks for coming, and I hope to see you at future MATHurdays and Mathagon events down the road. Thank you very much, everyone.
Thanks so much, David. We're always learning. We've used Mathagon a couple times in MATHurdays tasks, but I think just having this overview and the parallel play that we did, I know many of us were playing at the same time as we were listening, and we can see evidence of that on today's slide. Again, if you want to go back in there, we took some links and pictures of some of the other things that people were doing during the time. And now I'm really excited because one of our persons, Stephanie, had asked for prime and composite. So that's a future one. And we'll definitely use Mathagon in that along with some others. So thank you so much. I know my head is buzzing with ideas. I can see in the chat box, I'm not the only one. And so huge thanks to you. And folks, I'm going to get this recording up along with some of the past MATHurdays. I finally have a little bit of free time to get those up as well. And we'll just continue this journey where we look at representations and the connections that we can bring when students have a firm understanding of multiple visual representations. So thank you so much, everyone. Thanks so much to David Porras. And again, follow David. Did you want to put your Twitter information down there in the chat? Sure. If you want to keep seeing these nice little short videos of like, whoa, here's this other cool feature, I know David always puts them in.
And our, I spelled the last one wrong. We are on Twitter at Mathagon. ORG is like the main Mathagon account that also puts out things daily. I try not to overwhelm too much from the @David Porras account, but I do put some out. And like, I'm sure many of you are on Twitter. I've learned more, I think, in 2 years on Twitter as a math educator than in my many years as PD. And my district offers great PD. Like, I've been to some great conferences. My district does great stuff, but what I've learned on Twitter from many of you on the screen has been awesome. So hope to continue to connect with a lot of you out there. And if your head is spinning and you want to go learn more, obviously go watch this video, but mathagon.org/teachers has all our past webinars that you can go check out. Go explore the task page. There's a tutorial. Please reach out anytime with questions. I know there are a bunch of you ask questions on Twitter, which is great. Feel free to send me an email, which is on our site. Or give me a direct message on Twitter. Part of my role, Mathagon, is to help teachers do great things. So if you have questions, please know you're not bothering me. It's part of what I do at Mathagon, and it's really exciting to help teachers use the tool. That's what we're really excited about. So please reach out anytime with any questions. Or if you have great ideas that you want to add to our task page, we're always looking for folks beyond Mathagon to add tasks out there. So now I'll really stop talking. Thank you again, everybody.
Thanks so much. Thanks so much, everyone, for coming. Again, I'll stay on for a little bit afterwards if you have any questions. I know sometimes we just have some community building afterwards, but it is a beautiful Saturday out, at least where I am. Hopefully it's where you are too. So go enjoy it. And thanks again.
Morning. David, I have a question for you, if that's okay.
Yes, of course. Please.
Can you hear me? Sorry. One of the things, I actually have been using Mathagon and sharing it with teachers, but I did not even know there was a section called class openers and activities because it was kind of embedded alphabetically in that list.
Yeah.
So I'm wondering, should I go to the community and make a suggestion that is more obvious? Or, on the page, I'm just trying to remember the one where, when you've got the page where it says puzzles, activities, and lesson plans.
I do,
and that's where it kind of appears and it got lost for me.
Gotcha.
Is there a way, or even before that, when we click on activities, you've got Polypad, Timeline, Factress, if there's a place to just make it more obvious, I guess. And should I go put that in the community?
Yeah, so what you're suggesting is on the task page, that one with class openers and math talks is like a pretty valuable resource for teachers to try to like highlight that more.
Yes, because you've got more than just clocks, and you've got more than just tangrams. Like it's a place to house them. Yeah. I think that's a really valuable one. So should I go to the community and just throw it in?
I will jot that down, and we will talk about how to try to make that a little more prominent for teachers, so that is more helpful.
I don't know if you agree, if you think of it. I'm just thinking that that's an easy way for me to find things and an easy way for teachers to find stuff.
I think that is great feedback. It's alphabetical right now. What we've talked about, which we haven't come to a decision about, was in this, under file, there are all these examples and templates at the bottom. And so maybe a category down here could be class openers and math talks. Which does feel a little bit buried. If you're like mine and you have all these folders, that might feel buried a little bit. But I feel like if people have all these folders, they're probably pretty familiar with how the interface works. So maybe a class opener and math talks might go down there as well. What do you think about that, Kathy?
Yeah, just a thought. I think it's so valuable that as the community adds and as you add and other people add, I just think that's going to be a point of contact that will be really helpful.
Great. No, that is super helpful. And if there are ones that you think would be great to add to this list, I would love to have them. Our goal here is ones that teachers could continue, to go back to. So this example of the folding nets is kind of like a one-time use, right? Once you've done it, kids got it. But then here, there's a math talk where I just have kids spend a couple minutes, go try to build something. Go build a net, and then let's share it. That's a great opener to class, right? Just having kids go build something, and then that one with the card. So Great feedback. In addition, if there are ones that you and your colleagues have found successful as class openers, we'd love to add them here, and we'll definitely give you credit for your submission.
Okay, and I have just two more things. I was taking notes as we were going because I've come to a lot of your webinars. So you know how you can take the number bars and you can merge and you can split? Yeah. What I'm wondering about is it being able to do that with the fraction circles.
Yes.
Like can we take those same processes like the merge and split and bring it over to like a fraction circle that you make it in thirds and you split off 2/3 and a third, right? For the part whole, or I'm just wondering about some of those things. And should I tell you now or go put it in the community?
No, that's a great question. So currently in the fraction bars, there's an option to split and then
for bars,
right?
Okay,
the
but
bars,
not the circles.
And then I could merge them back together and do the shading thing. But I think what is a really powerful tool on the bars is there's an option at the bottom to rename. And so you know, if I have something like that, it'll change them based on the fraction that I have into fractions with different denominators. And so your suggestion would be the same ability with the fraction circles. You don't need to.
Absolutely. Because when I was doing that and I was trying, and thank you for telling us how to make a circle easily, because I was using C and getting 6 pieces, 6, trying to put it together. It took forever. So I like how you did it. But yes, I'd like the same options on the fraction circle. So you can split and merge. And
that's a great suggestion. I've written both of those down, so you don't need to put them anywhere else.
Okay.
They will make it on the list. What is exciting and sometimes frustrating is we have a lot of things on the list and awesome suggestions. No, like those are great suggestions that would be really valuable for teachers. So, and I know that Philip, our founder and CEO, is excited to get all the suggestions out there. It's a really small team of coders. There's like 3 or 4 people, and except for and Philip is the only one this is like their full-time job. We have some folks who are students and do other work, and I'm part-time. So it can take a while for those suggestions sometimes to be implemented, but it's not for a lack of interest or a belief that it's a good suggestion.
Well, but you are responsive, and that I think shines through with Mathagon, because we suggest things, and even if it's not done right away, we know that things are under constant development. Absolutely. So as a consultant, I'm able to communicate with them, submit ideas. So that's been really good. One of my, just a little positive feedback, and I'll stop talking, is one of my colleagues who is a consultant is teaching high school math in a virtual world now. She did not know about Mathagon. So I went and took her, showed her some samples, and she now has gone to the principal and said, I need access. Do we have permissions, right, with all of the FOIP things? Right, exactly. And she is just now sharing it with all her high school colleagues about how powerful this is. So,
thank you.
Yay!
That's great. Thank you for sharing. And thank you for coming to this webinar and past ones. And if you ever have suggestions for me to make these more valuable, like I have thick skin and I can take it. And the goal of these is for it to be helpful. Right? Like people can go log off of Zoom anytime they want, and I probably wouldn't notice. So feel free to send me an email, david@mathagon.org, with like, it'd be better if you like, I would welcome that feedback. Just like teachers, we're all trying to do our best work and make it valuable time. So thanks for all the questions, Kathy.
All right, folks, have a wonderful rest of your Saturday. Thanks for coming. Thanks again, David.
Thanks to you too, Teresa. I want to show you.
Yay!
I took your idea. I went and got a mug. I also have this on here.
Beautiful.
So this is going to be my mug. I use this during sessions.
Nice.
And then people ask me what it is, and I go, let me tell you.
Very cool.
So thank you. Thank you. Have a great week, everybody.
Thanks for having me, Teresa. I really enjoyed it.
This has been a blast. I'll make sure that I, spread it around. I think when people network and spread it through their different networks too, it can help bring awareness to more people. So thanks a bunch, and look forward to continue our communication.
Awesome. Thank you. We'll be in touch down the road, I hope.
All right. Sounds good.
And maybe one of these days in person if they ever have conferences again or anything.
Great.
Thanks very much.
All right. Take care.
Have a great day. Bye-bye.